Kinematics of spring block oscillators. One key term that we use to measure the motion and kinematics of spring block oscillators is period. Period is the amount of time for a spring to undergo one full oscillation. So what does a full oscillation look like? So let's draw a spring at rest. We'll say that this is at rest here. Okay, and we have a block hanging at the end. So when the block would start at rest, would stretch out to a lower position, would return to being at rest, would compress, and then it would finally return to its equilibrium position. So it starts at rest, bounces down, comes back up, compresses slightly, and then comes back down again. That is one full oscillation. So that's one oscillation. Now, when we talk about period, so let's say we have a period of t equals 2 seconds. That means it takes 2 seconds for one oscillation. Now, this differs from the next term, which is frequency. Frequency is actually the number of oscillations per second. It's the inverse of period, whereas period is the inverse of frequency. So when we talk about frequency, let's say we have a frequency of 2 hertz, okay? Just to go with the same number so we can see the difference. So a frequency of 2 hertz means the complete opposite. It means 2 cycles complete in 1 second. Okay, so it's completely different. 2 hertz means 2 cycles complete in 1 second. 4 hertz means 4 cycles in 1 second, etc., etc. All right, so a couple of key characteristics about spring block oscillators and frequency and period again. So frequency and period are unrelated to how far you stretch the string. So I could pull the string down, 10 feet, and then let it go, or I could compress it to the very top, compress it 10 feet. No matter how far you stretch or compress the spring, this does not affect the period and frequency. We'll see there are only 2 things that affect the frequency and the period, and that is the mass of the block that you hang and the spring constant K. So those are the 2 factors that affect the period and frequency. And the last bullet point is, in simple harmonic motion, energy travels back and forth between the form of kinetic energy and potential energy. So when it's moving, it's kinetic energy, and there might also be some potential. When the block is at the top, there's both potential in terms of gravity and the spring, but the energy transfers between these 2 forms. The total energy, however, always stays the same. All right, next slide. Let's look at a couple of important formulas that we need to know. So I want you to ignore these top 2 formulas for just one moment. I want you to look at these formulas here. So the major formulas that we need to know are that frequency is the inverse or the reciprocal of period, so it's 1 over period, and period is likewise the reciprocal of frequency. So I'm going to write over here 2 additional definitions for these. So for frequency, frequency is calculated as cycles over time. Whereas, if you can guess, period is time over cycles. So it's the reciprocal. And then here are 2 additional equations very specific to spring block oscillators. And you can see that the only 2 factors that affect frequency and period are the mass of the block and the spring constant K. Okay, just a quick reminder. For period, the unit is seconds, and for frequency, the unit is hertz. Hertz is actually a unit of, it's 1 over seconds, or seconds to the -1.